Imagine you're standing on the floor of a massive, really bustling casino. You walk up to a roulette table and you just watch the croupier spin the wheel.
Right, the classic casino setup.
Yeah, and from a microscopic perspective, the exact moment that little white ball leaves the dealer's hand, it just enters the state of pure, unpredictable chaos.
Oh, absolutely. I mean, it's bouncing off the wooden rim, colliding with those little metal deflectors, skittering all over the numbered pockets.
Exactly. There are just so many tiny, infinitesimal variables at play that predicting exactly where the ball will land feels, well, mathematically impossible. It's a pure dice roll.
And a lot of modern thinkers look at that bouncing ball and they say, well, that is human life.
Right.
They argue that at our core, we are entirely at the mercy of random, chaotic forces. And so because of that, human destiny is completely unpredictable.
Which is, it's a deeply unsettling thought for a lot of people.
Oh, for sure. If the universe is fundamentally random, then this whole concept of personal agency, the idea that our choices actually matter, it starts to feel like just a comforting illusion.
Okay, let's unpack this.
Okay.
Because we are putting that exact assumption under the microscope today.
We really are.
We're diving into this really thought-provoking 2023 essay by Zhuofeng, which was actually translated by Kinyu. And it's titled Uncertainty Principle in Quantum Mechanics and Human Destiny.
It's a heavy title, but it's a fascinating read.
It is. And the core mission of this deep dive is to explore this massive collision between two totally opposite worldviews.
Right. So on one side, you've got the modern critics who use quantum physics to argue that life is just, random.
And on the other side, Zhuofeng presents this ancient, deeply rooted spiritual philosophy that human destiny is actually rigidly predictable.
Yeah, it's built on this idea of the conservation of energy, where the positive and negative energies of the universe always balance out to zero.
Which is essentially just a physics-based framing of the old proverb, as you sow, so shall you reap.
Exactly. The argument is that your daily psychological activities, your words, your behaviors, even something as subtle as your physical posture, are actively and mathematically writing a very specific, determined future for you.
So if you are listening to this right now, think about your own life. We all want to know if, packing our lunch, going to work, and making good choices today will actually guarantee a secure future.
Right? Or are you just that roulette ball, bouncing aimlessly through a chaotic universe where your choices are ultimately overridden by random chance?
It's probably the biggest question a person can ask. But, to understand how critics defend the idea that destiny is a random dice roll, we really have to start by defining the actual science they're relying on.
We do. We need to go down into the microscopic world and actually look at the chaos they're pointing to.
And what's incredibly helpful about this essay is that it avoids burying us in heavy academic jargon, right? It breaks the scientific defense down into fundamental concepts, starting with Brownian motion.
Yeah, Brownian motion. So if you put a drop of water under a powerful microscope and watch the molecules, you don't see them moving in some neat, orderly parade.
No, not at all.
You see absolute erratic chaos. The molecules are constantly aimlessly colliding with each other in the dark. There's no pattern, no destination. It's just an endless, irregular mosh pit of particles.
An erratic mosh pit, yeah.
Yeah.
But the real breakdown of predictability happens when you zoom in even further, right? Past the molecules, down into the realm of quantum mechanics.
Yeah.
And I want to pause here because the way quantum is explained in the text is brilliant. In our normal everyday lives, we're used to measuring things on a smooth, continuous scale.
Like a piece of string.
Exactly. A piece of string can be 2 meters long, or it could be 1.5 meters or 1.259 meters. You can just keep zooming in and dividing that string into infinitely smaller decimals.
And that was actually the assumption of classical Newtonian physics, too. Energy was thought to flow continuously, like water pouring smoothly out of a faucet.
Right.
But then the physicist Max Planck completely shattered that idea. He discovered that at the most fundamental level, the flow of electromagnetic energy isn't a smooth stream at all. It occurs in discrete, indivisible packets.
And the essay uses this fantastic analogy about a pen full of sheep to make this tangible.
Oh, I love the sheep analogy.
Right. If you are standing in a field counting sheep, you can count 13 sheep, or you can count 14 sheep. But you absolutely cannot have 13.48 sheep.
You literally can't.
The universe, at its absolute base layer, just stops using fractions. It only deals in whole numbers. And Planck coined the term quantum to describe that smallest possible indivisible packet of energy.
Which, triggered a total scientific panic at the time because it meant classical physics was fundamentally broken. And this directly led to Einstein's work on the photoelectric effect. So Einstein found that if you shine sunlight onto a metal plate, the light can actually knock electrons out of the metal, creating an electric current.
Okay, making sense so far.
But here's the critical part. The electrons aren't knocked loose by how bright or intense the light is. You could shine a blindingly bright red light on the metal and get absolutely nothing.
Wait, really? Nothing at all?
Nothing, but a very dim blue light, which has a higher frequency, would knock the electrons loose immediately.
Because it proved that light isn't just a wave, right? It also acts as a particle, a photon. It has wave-particle duality.
Exactly. And the smallest measurable unit of that photon's energy is a quantum.
So now the scientific community is just reeling because particles are acting like waves, energy is moving in these chunky packets instead of smooth streams, and everything they thought they knew about a predictable clockwork universe is just falling apart.
Totally falling apart. And that collapse of the clockwork universe brings us to the crown jewel of the critics' argument, Heisenberg's uncertainty principle.
Right. And the essay clarifies that a better, more accurate translation of this is actually the principle of indeterminacy.
Yes, indeterminacy. The concept is that in the microscopic quantum world, if you accurately determine a particle's position, its momentum, like its velocity, becomes inherently uncertain.
And conversely, if you accurately measure how fast it's moving, its physical position suddenly blurs into this haze of probabilities. You literally cannot know both at the same time. Let me try to map this onto something I know to really grasp the scale of the weirdness here.
Go for it.
So in our everyday macroscopic world, if I am a police officer with a radar gun on the highway, and I clock a car traveling exactly 100 kilometers per hour, and I know 10 seconds have passed, I can calculate exactly where that car is down the road.
Right. Basic math.
But down in the quantum realm, the more perfectly I calibrate my radar gun to know the particle speed, the more its physical location literally vanishes from reality.
It vanishes from determinable reality, yes. Because to measure the particle's speed, you have to interact with it, say, by bouncing a photon off of it, which inherently alters its position. It forces a massive shift in perspective.
That is wild.
It is. And because of this indeterminacy, particles like electrons are understood to exist in a superposition. They aren't in one specific state or location.
Right, they exist as a cloud of probabilities.
Exactly. Acting as both wave and particle simultaneously until an observer forces them to take a fixed form.
Which naturally brings us to the most famous and honestly probably the unluckiest animal in all of science, Schrödinger's cat.
Oh, the poor cat.
Yeah.
So Erwin Schrödinger proposed this thought experiment to highlight how bizarre this all was.
Lay it out for us.
Imagine a cat placed in a sealed steel box with a tiny amount of radioactive material, a Geiger counter, and a vial of poison.
Okay.
If the radioactive atom decays, which is a completely random, unpredictable quantum event, the Geiger counter triggers a hammer that smashes the poison, and the cat dies. If the atom doesn't decay, the cat lives.
But because that atom exists in a quantum superposition of both decayed and not decayed until someone looks at it, quantum mechanics implies that the cat inside the box is simultaneously both dead and alive.
Yeah. It exists in two mutually exclusive states at once, completely suspended in uncertainty until you open the lid.
And Schrödinger meant this to be a joke. Right? Like pointing out how absurd quantum theory becomes when you apply it to everyday objects.
He did. But as the essay notes, some physicists took it very seriously. An American scientist named Hugh Everett proposed the many worlds interpretation, or parallel universes, to solve the cat problem.
Oh, the multiverse theory.
Exactly. He argued the superposition doesn't just suddenly collapse when you open the box. Instead, reality itself physically splits.
Whoa.
Yeah. In one universe, you open the box and find a live cat. In a newly created parallel universe, a version of you opens the box and finds a dead cat.
It is just entirely mind-bending. But, Schwiffing isn't giving us a history lesson on quantum mechanics just for the fun of it.
No, not at all. What's fascinating here is how deliberately the essay uses these specific concepts. The author isn't laying out Schrödinger's cat and parallel universes to concede the point that our lives are random.
Right, it's a setup.
Exactly. They are meticulously building up the critic's fortress, showing exactly why people believe the universe is an unpredictable dice roll, just so they can dismantle it entirely with a philosophical rebuttal.
Here's where it gets really interesting. The author takes that entire quantum foundation and just flips it.
They do.
The critics say, look at the uncertainty principle. Look at the microscopic chaos. Therefore, human destiny is a random game of chance. And Swoofeng counters with a hard, absolutely not.
The core of the rebuttal is the fundamental divide between the macro and the micro.
Right.
The argument is that just because the invisible subatomic world is governed by splitting universes and unknowable positions, that does not mean our microscopic everyday reality operates under those same bizarre rules.
So the premise is that in the world, we actually inhabit the macro world. Sir Isaac Newton and his predictable laws of motion still completely overrule quantum indeterminacy.
Yes. And the essay grounds this with a scenario that anyone listening can relate to. Think about your drive home from a road trip.
Okay, I'm picturing it.
If you are 300 kilometers away from your house and you get on the highway and maintain a steady speed of 100 kilometers per hour, you will arrive in your driveway in exactly 3 hours.
Right, barring traffic.
Exactly. That is a definite locked-in reality. It is as mathematically certain as 5 plus 3 equals 8. The fact that the electrons inside the car's engine are vibrating in an unknowable state of quantum superposition, it doesn't change the macroscopic reality that you will pull into your driveway right on time.
Which exposes what the essay identifies as a massive category error made by the critics.
A huge one. In modern culture, people hear the word quantum and they immediately start applying it to everything, right? Quantum healing, quantum consciousness, quantum destiny.
Oh, absolutely. It's everywhere.
But the author emphasizes a crucial point we established earlier. A quantum is purely a unit for measuring energy. It is not a physical substance.
It's not a molecule or an atom.
Right. Using a microscopic unit of energy measurement to evaluate the complex macroscopic trajectory of human life choices is a profound conceptual mistake.
But hold on, I have to challenge this logic based on the essay's own admissions.
Okay, let's hear it.
Well, Xu Feng acknowledges that the human body is entirely constructed out of microscopic particles, right? Including electrons.
Yeah, that is biologically true.
And we just spent the first half of this deep dive establishing that electrons are ruled by wave-particle duality and the uncertainty principle.
We did.
So if I am quite literally built out of billions of chaotic, uncertain, unpredictable microscopic parts, shouldn't the rules of those chaotic parts dictate the overall rules of my destiny? Like, how can I escape the physics of my own building blocks?
It's the exact right question to ask, and the essay actually anticipates this pushback perfectly with an analogy about carbon.
Okay, tell me about the carbon.
So if you look at graphite to lead in a common pencil and a diamond, you are looking at two materials that are 100% identical at the microscopic level. They are both made entirely of carbon atoms.
But their physical reality is going to be more different. I mean, graphite is dark, opaque, and so soft it literally flakes off onto a piece of paper when you press on it.
Yeah. And a diamond is brilliantly transparent and is one of the hardest naturally occurring substances on the planet. It can cut glass.
Precisely. The macroscopic properties are vastly different because of how those atoms are structured and aligned.
And the essay's point is that you cannot infer the characteristics of a diamond by studying the softness of graphite, even though their microscopic building blocks are the exact same carbon atoms.
You cannot treat a pencil's core like a diamond.
Right. And by that same logic, you cannot take the bizarre, unpredictable rules of an isolated electron and use them to predict the behavior of a fully formed human being. When parts combine into a complex macro system, emergence happens. The sum of the parts creates an entirely new set of rules.
That distinction really clears the fog. And once the essay successfully strips quantum mechanics of its power to dictate our macro lives, the narrative pivots.
It does.
Xuefeng moves from defense to offense, laying out the case for why our everyday outcomes are actually rigidly determined by our actions. We are back to the ancient rule, as you sow, so shall you reap.
And the examples used here are uncompromising. The author is arguing for absolute, undeniable causality in human action.
The analogies are incredibly grounded, too.
Yep.
Xuefeng points out that if you plant a watermelon seed in the dirt, it is a determined biological fact that watermelon vines will grow and watermelons will be harvested.
You don't stand over the soil, invoke the uncertainty principle, and wonder if maybe roses will bloom instead.
Exactly. The specific action mathematically dictates the specific outcome. And the essay extends this direct causality to human morality and behavior.
Which is where it gets really heavy.
Yeah. The argument states that if a person is fiercely lazy, selfish, and refuses to contribute to society, it is a determined macro fact that they will eventually encounter poverty and hardship. If an official is continuously corrupt and accepts bribes, their ultimate inescapable destination is a prison cell.
If we connect this to the bigger picture, the casino analogy we used earlier perfectly illustrates this transition from micro-chaos to macro-destiny.
Oh, right. Let's bring that back.
So when you watch that roulette wheel spin, the individual bounce of the ball is a chaotic, unpredictable event.
Hmm.
But consider the macroscopic destiny of a habitual gambler who sits at that table every single day. The casino's mathematical edge guarantees that over time, the gambler will lose everything.
Wow, yeah. The micro event has wild variance, but the macro destiny of the gambler's life is absolutely fixed by their pattern of behavior.
It's a terrifyingly clear way to look at our habits. We're constantly observing how order emerges out of chaos. And the essay actually provides two brilliant visual models to help us see how human beings transition from aimless wandering into absolute destiny.
Let's look at the railway station first.
Okay, so if you were to stand on a high balcony overlooking a massive crowded train station during rush hour, the surging crowd looks identical to Brownian motion under a microscope.
Just a sea of aimless, chaotic movement.
Exactly. People are bumping into each other, darting sideways, stopping randomly. From up there, it looks like pure uncertainty.
But that is an illusion created by distance, right? If you walk down the stairs and actually look at the individual people on the floor, the chaos disappears. Every single person in that station is holding a ticket. They're walking with intention toward a specific platform to board a specific train to a highly specific, predetermined destination.
The randomness only exists if you aren't paying attention to the intention.
Which sets up the final and arguably most important physics analogy in the essay, the magnetized iron.
Yes, this is the core mechanism of how Xu Feng believes human destiny is shaped.
Normally, the molecules inside a regular rod of iron are just bouncing around aimlessly, reacting to each other with equal random force. It's the exact thermal agitation and Brownian motion we've been discussing.
Right, yeah.
But if you wrap a coil of wire around that iron rod and pass a strong electric current through it, the iron becomes an electromagnet.
And the introduction of that current changes the internal reality of the material instantly.
Instantly. The chaotic bouncing just stops. The magnetic domains inside the iron suddenly snap into alignment.
All those random electrons begin to move uniformly in the exact same direction.
Yeah, the chaotic, unpredictable energy is replaced by a powerful, unified, and determined force.
To anchor this concept, the essay draws on the ancient wisdom of Laozi. The author quotes, "Divine punishments, though slow, are always sure, with big meshes, yet letting nothing slip through." It represents a universal ledger of cause and effect. What you did in the past created your present reality. And the current you are passing through your life right now, your daily intentions, your focused actions, is strictly and predictably determining your future.
So the universe isn't a casino rolling dice. It's an impeccably accurate accounting system.
Exactly. Now, everything we've discussed so far has been broad philosophy and physics, but here, the essay shifts gears from the theoretical to a highly specific, real-world application.
Right. Xu Feng isn't just writing this as a philosophical exercise. The text is directed at a specific community to explain who exactly is being magnetized in this way.
Yes, the focus turns to a group referred to as the Chenyuan Celestials. And, to be entirely clear for our listeners, our goal here is to impartially map out the author's framework so we can fully understand the essay's conclusion without necessarily endorsing the theology behind it.
Right, of course. We're just looking at the text. Xu Feng explains that before this specific group of people came together, they were living lives that resembled random Brownian motion.
They were the unmagnetized iron.
Exactly. Just bouncing through society without a unified, overarching direction, completely susceptible to all the chaotic forces around them.
But Xu Feng makes a very specific claim about their own role in this dynamic. By guiding this community onto what the text calls the Tao of the greatest creator and the path of Lifechanyuan, the author asserts that they are acting as that electric current on the iron rod.
Xu Feng claims to be continuously infusing spiritual and philosophical energy into the group.
Yeah, and according to the logic of the essay, the result of that spiritual current is that all the chaotic individuals in the group have snapped into alignment.
They are now moving uniformly toward a very specific, determined destiny, which the text identifies as the Celestial Islands continent.
The argument is that once a clear spiritual direction is established and actively energized by intention, quantum uncertainty just vanishes from the equation entirely. The destination becomes a fixed, inescapable point.
And the essay drives this final point home with a very relatable, Honestly, almost humorous analogy about international travel.
Oh, this one's great.
Imagine I stand up in a crowded room and yell, "Who wants to go to South Africa? Follow me." A few people raise their hands. So I take their passports, I process their visas, I buy the non-refundable plane tickets, I pack their luggage, and I pre-book the hotel rooms in Cape Town.
Right. When you take all of those concrete macro actions, the outcome is locked in.
Exactly. Those people are going to South Africa. The essay points out how ridiculous it would be for someone to suddenly stand up, invoke the uncertainty principle of quantum mechanics, and say, well, who knows? Reality is just a superposition of probabilities. They might end up in the UK instead.
Right, no. The tickets are booked, the visas are stamped.
The concentrated intention created a determined physical reality that completely overrides microscopic chaos.
So what does this all mean for you, the person listening right now? It's an invitation to examine the physics of your own life.
Are you operating in a state of aimless Brownian motion, just bouncing off whatever circumstances or crises hit you today?
Or have you intentionally passed a current through your own life? Have you aligned your daily actions to magnetize your trajectory toward a clear, undeniable destination?
It's a remarkably empowering way to view our choices. As we wrap up this deep dive, it's wild to look back at the sheer distance we've covered today.
It really is.
We started by staring into the confusing, splitting realities of Schrödinger's cat and the panic of quantum indeterminacy, and we ended up in the deeply grounded, dirt-under-your-fingernails reality of planting watermelon seeds.
Yeah, we've seen how Shofang meticulously defends the ancient law of cause and effect by proving that the randomness of quantum physics simply does not apply to the macroscopic reality of human intention.
It is a rigorous, physics-based defense of personal agency.
But this raises an important question, something that builds on the essay's analogies about magnets and train stations.
How's that?
Well, we spent this time talking about how one individual's focused intentions act like a current, aligning their chaotic microscopic parts into a determined future. But what if we zoom out even further?
Okay, I'm tracking.
Could our collective human intentions act as a macro magnet for the entire planet? If individually packing a bag guarantees a trip to South Africa, what future is humanity collectively packing its bags for right now?
Oh, wow. Are we, as a society, collectively buying tickets to a destination we actually want to arrive at, or are we just throwing our hand up and hoping the cosmic dice roll in our favor?
Something to think about.
That is definitely something to mull over on your commute today. Thank you for joining us on this deep dive. We started by looking through a microscope at pure chaos, but maybe the most important thing to examine is the magnet you're holding in your own hands. We'll see you next time.